Good morning, all of you. In the last class, we have learned motion of object along the principal axis in case of concave mirror, right? So in today's class, we will learn this motion of object transfers to the principal axis, right? So let's see motion of object transfers to the principal axis. Now, first of all, what is transverse and what is along? Yes. So already I told along means parallel or along the principal axis. I'm just giving you a rough idea here. You can just see. Suppose this is a mirror. Yes, this is a mirror. And now any object is moving. So here it is object. So when this is moving like this, that is along the principal axis, then it is along. Or even you can say parallel, sometimes along the principal axis. Another one you see here like this, sometimes object may move. This is what? Transverse. What is this? Transverse. See how it is moving? Principal axis is like this, object is moving up or even down also, because it should be perpendicular to the principal axis. But in case of along means it should be like this, along the principal axis. Understand? So in the last class we have finished this along the principal axis. So today we will learn this transverse. Okay. So how the motion of object is. Let's see. So first let me draw the diagram of this object which is moving transverse to the principal axis in case of concave mirror. Okay. So here is concave mirror. Can you see? This is a concave mirror. And now let's take an object which is moving transverse to the principal axis. This is your principal axis. Okay. Now I'm keeping object beyond center of curvature. Okay. Here I'm keeping object beyond center of curvature. This is your focus. And let us suppose here is center of curvature. Now I'm keeping object here beyond C, and that is also moving. How it is moving? Along the or transverse to the principal axis. So I'm keeping little dots here, okay, as it is moving. Now as object is here, let us suppose it is moving with velocity v naught. V naught is what here? V naught is what? Object velocity. What is v naught? Object velocity. It is moving here. And now this is its image. Yes, this is the image, and let us suppose it is moving with velocity vi. What is this? Image velocity. What is this? Image velocity. and of course here it is what pole of the mirror. Now basically if we will see here in the diagram, can you see this total distance from this pole is what object distance. What is this? Object distance. So can I denote here as a u? Yes, I can. This is a u. And then this distance where this image is getting formed and this image is also moving with some velocity, that is vi. I'm denoting it with phi. Phi is what here? Image distance. Keep it in mind. Now, so if I want magnification, magnification formula is what? Magnification m is equal to hi by h naught. What is this? Hi by h naught. And this is equal to phi by u. Okay. This is nothing but minus m, we can say. Or even you can keep here minus also. Not an issue. Right? So this is minus v by u. M is equal to hi by h naught is equal to minus v by u. This is what? Magnification formula in terms of height and velocity. In terms of height and velocity. Clear? Okay. Now, what I am doing, see, this one, that is, I am taking just this formula. M is equal to hi by h naught. See here, as this object is moving, the height of this object is variable, as well as here also it is varying. Means the distance, vertical distance is changing with respect to time. Therefore, can I do like this? This is minus m. Okay. So here I am doing like this. Differentiating this. So d hi by dt divided by d h naught by dt is equal to minus m. The rate of change of height distance of object divided by rate of change of object height. Yes. So here it is minus m is equal to, can I write like this? This is vi divided by v naught. And therefore I am getting velocity of image is equal to minus m into velocity of object. Yes, velocity of image is equal to minus m into velocity of object. Yes. This is what we got formula for image velocity and object velocity when object is moving transverse, that is perpendicular to the principal axis. Understood? Yes. Note down this. If you want, you can write some part here like this. That is, phi is what? Image distance. Okay, what is this phi? Image distance. At what image, what distance image is moving? U is what? Object distance. U is what? Object distance. Next, hi. Hi is what? Height of image. Yes. H0 is what here? Height of object. Yes. Next one, VI. VI is what? Not image distance. This is what? Velocity of image, right? And V naught is velocity of object, right? So note down. Okay, right? Understood? Let's move ahead. Next. Now, next topic is what is power of curve mirror? What is next topic? Power of curved mirror. Power of curved mirror. So can I write like this? See here, definition of this is the reciprocal of focal length. What is this? Reciprocal of focal length. Let's see how it is. Reciprocal of focal length. So therefore, P in diopter is equal to 1 by F in meter. 1 by F in meter. That is equal to 100 by F in centimeter. This already you know. Yes. So if focal length they have given in meter, you use direct 1 by F formula. If focal length is in centimeter, you just divide, or you just divide that focal length to 100, right? One small example we will take. Already you know this. See here. Find focal length of concave mirror or first if focal length he is asking, let it find focal length of concave mirror of power of power 2D. D means what here? Diopter. That is SI unit of power. How to solve? Let's see here. Now what is given? What is given in this problem? Given is P, that is power, is how much? 2 diopter. Is it in SI? Yes, it is in SI. No need to convert. So here P is equal to 1 by F. So therefore F is equal to 1 by P. But which mirror is this? Concave mirror. Which mirror is this? Concave mirror. If you will see in the diagram here, you see this is a concave mirror, and see what I'm doing. I'm just telling you how to take sign. This is focus, and here is a pole. So you are going from pole to this side because light is going to fall in this direction. So you are against the light direction. So whatever this focal length is there, is it negative or positive? This is negative. So therefore, f is equal to 1 by 2, and that is also minus. So therefore, 1 by 2 is how much? Minus 0.5 meter. If you want to convert into centimeter, then f is equal to minus 50 centimeter. This is what your focal length is. Sir, for which mirror it is positive and which mirror it is negative? Let's see here. I'm writing one box I'm giving you. So see here in this box. For convex mirror, for convex mirror, F is positive and for concave mirror, F is negative. Keep it in mind always. Convex mirror, focal length is positive. Concave mirror, focal length is negative. Understood? So whenever you want to find anything, we can do like this. Okay, note down this. Yes, finished. Okay, let's move ahead. Next one, if we will plot the graphs, right? So what happens? Let's see. In case of these curved mirrors, how many graphs we can plot and what are or what calculations we are going to do? Let's see. First one, I'm plotting graph that is V versus U. If suppose we have plotted graph like this, that is I have taken V on y-axis and U on x-axis. What we did, V we have taken here, U we have taken this side. On y-axis V and on x-axis U. So if you will plot graph, you will get the nature of graph is something like this. Something like this. Can you see? Or else you can draw with freehand also. If you will draw with freehand, The graph nature will be something like this. Okay, like this. So initially, when your u is less, v will be more, and as you are increasing the u, v will start decreasing. V will start decreasing. Then what to do if you want to find focal length from this graph? You just draw perpendicular here like this, which makes angle 45 degree. How much this angle is? 45 degree. And then you just take this point and draw two perpendiculars on this x and y axis like this. So this is your origin O, this point is A, this point is B. Got it? This graph already you have plotted. Now what to do? Take angle 45 degree and draw one line and then draw two perpendiculars on x and y axis. How to find focal length from this graph? So f is equal to, just measure this distance OA plus this OB, measure this distance also, and just divide it by 4, you will get focal length from this graph. Clear? This is what V versus U graph. Second graph I am plotting, that is 1 by V versus 1 by U. You see here. Which graph I am plotting? 1 by V versus 1 by U. So on this y-axis, I am taking 1 by V. On this, I am taking 1 by U. What I have taken on x-axis? 1 by V or 1 by U. 1 by U. Yes. And on y-axis, 1 by V. Right? On x-axis, 1 by U you take, and on y-axis, 1 by V. Right? So here you see what type of graph you are getting, the nature of this graph. If you will plot this graph, you will get one straight line like this, which is having negative slope, we can say. So if you are getting like this line, just give this point as a O, this point is A, and this point is as a B. And if suppose you want to find focal length, then from this graph, F is equal to 2 divided by OA plus OB. Right? So from these graphs, we can find out focal length of the curve mirror. How many graphs we have seen? Two graphs. One is V versus U, another is 1 by V versus 1 by U. If V by U graph you are plotting, focal length formula is OA plus OB by 4, and here 1 by V versus 1 by U graph, focal length formula is 2 by OA plus OB. Yes, draw this graph. Let's move ahead. Now, let's learn Newton's formula. What is that? Newton's formula. This Newton's formula is what? See, here in this Newton's formula, here object distance, object distance is x1, is x1, and image distance, and image distance is x2 with respect to focus, with respect to focus instead of pole. This is very important line, instead of pole. Okay, in Newton's formula I will tell you one example. See here, suppose this is a concave mirror. Yes, this is a concave mirror, and this is a principal axis. This is focus, this is center of curvature, and here is a pole. Suppose now object is here somewhere. Where is object? Beyond center of curvature. So in generally, how we are measuring the distance? This will be your u, yes or not? But in this Newton's formula, you should measure distances all from focus. That's why this is the x1. Understand? And suppose here is your image. Let us suppose here is your image somewhere. Okay. So where is your x2? This one is your x2. From focus only. Understand? From focus only. All distances should be measured from the focus. And if we will measure from this pole, this is what your v is. This is v. But which one we are taking? Only this and this. Always from the focus. So let's see how we are going to derive this formula. So first of all, we know 1 by f is equal to 1 by v plus 1 by u. 1 by v plus 1 by u. Now, see here. At the place of this v, what I can write, this is already, you know, this is what focal length from pole to focus. So here 1 by v is what? F plus x2. So this is what? F plus x2 plus 1 by u, F plus x1, right? Because already from pole to F is focal length. Focal length plus this x2 is your what? Image distance. Focal length plus this x1 is what? Your object distance. So just you have to replace this u. So I'm writing here u is equal to F plus x1. V is equal to F plus x2. Understand? Because you see here object distance is x1 and image distance is x2 with respect to focus. Keep it in mind. Let's move ahead, and then 1 by f is equal to, if we will solve this, that is f plus x1, this into this, plus f plus x2 divided by f plus x2 into f plus x1. If we will solve this, we will get x1 into x2 is equal to f square, and therefore we'll get f is equal to under root of x1 into x2. What we will get? F is equal to root of x1 into x2. What is x1 here? What is x1? Object distance from the focus. What is x2? Image distance from the focus. Always from the focus. Keep it in mind. With respect to focus, all distances we are measuring with respect to focus in the Newton's formula. Clear? Understood? Yes? Note down this. Okay, finished? Let's move ahead. Now, let's solve one small problem. One example on this model. X1 is equal to 20 centimeter and x2 is equal to 10 centimeter. Find focal length. Find focal length of each mirror, concave or convex? Concave mirror. So can you do it now? F is equal to under root of x1 into x2. So just take both minus minus. So F is equal to root of minus 20 into minus 10, and then this is under root of 200. Yes, so F is equal to 100 into 2. Yes, 100 into 2. So what you are getting? 10 root 2. 10 root 2. Again, if this is concave mirror, you will get focal length obviously as a minus 10 root 2. Okay. You can do this, just example, you try to understand. You can do according to your wish how many you want. Just this is a small example I have told you how to solve by using the Newton's formula. Okay, so let's stop here for today.